Good morning. Am I audible? Can somebody confirm? Hello, am I audible? Yes, those who have joined, can one of you confirm if I'm audible? Jeffrey, Prashad, Ravi, and I can see a few more people. Can anyone confirm if I'm audible?
Yeah, you are perfectly audible.
All right. Okay, cool. So we have a few minutes to go before we go live. People are still joining in. Those who have joined, please feel free to maybe introduce yourself in a couple of lines. You may also mention anything particular in realm of today's discussion you would like us to, any topic that you would like us to take up. We would be happy to incorporate all those suggestions as best as possible. So please feel free to maybe introduce yourself in like one or two lines, and also please feel free to mention any particular topic or area of discussion in realm of today's topic you want us to take up. You can put in all in the chat window. Of course, you can put your questions later on as well as the session progresses. We will be taking up all those in the Q&A session. But now also, like anything specific, in context of today's topic, you want us to take up, we would be happy to take up if possible, right? So please feel free to mention anything particular that you would like to hear from us in context of today's discussion. You can type in the chat window any particular area within today's topic that you wish us to take up. Or also please feel free to introduce yourself maybe in one or two lines. You can all share all this information in the chat window. So first of all, a very, very warm welcome to all of you for joining today's webinar session. A very, very good morning. Today's webinar topic, as you all know, is on AI and ML applications in credit risk. And the webinar is part of our webinar series, Deep Dives with IIQF Experts. So as you all know, we regularly conduct webinars on various important topics related to quantitative finance, financial engineering, risk management, algorithmic trading, AI, ML, data science applications in finance. So today's topic, in fact, actually combines two very interesting areas and hot areas. AI and ML, artificial intelligence, machine learning is definitely one of the hottest areas across all industries, and I mean, including our finance. So we do apply machine learning and data science and AI in various aspects of finance. Particularly, we would be understanding about applications of AI and AML models in the area of credit risk, which is one of the most used area of I mean, ML data science in finance, right? And we are very happy to have with us Ritesh, who would be presenting us the topic. And I mean, just to briefly introduce Ritesh, Ritesh is a seasoned banker with I mean, more than 14 years experience in credit and risk management, and he has been working as the president of a leading private sector bank. Prior to that, he was in IT consulting and had worked in various roles in India, China, and Canada. Ritesh is very, very passionate about teaching, and I can vouch for that. I mean, we have long been associated in IIQF with Ritesh almost for a decade now, and he has been conducting workshops and trainings for the last 6-7 years. His area of interest are credit risk, quantitative finance, statistical learning. Ritesh is a PGDM from IIM Calcutta, and he's an engineer from IIT Kanpur. He's also a member of the Board of Studies in the area of finance management at IMT CDL at Ghaziabad. Right. So thanks once again for joining, Ritesh. Thanks for taking your time. A very, very warm welcome.
Yeah, good morning, everyone, and thank you, Nitish, for inviting me over.
Right. Thank you for joining. Before I hand over the session to you, but I'll briefly lay out how we would go about the session. So most of you have the session planned, but still, just to mention. So anyway, like this session would be of about 1 hour, and followed by a Q&A. So please feel free to, during the session, after the session, now, whenever you have any questions, queries, please feel free to type your questions in the chat window. We would try to take up every question post the session. So please feel free to interact. We want to hear from you, want the session to be interactive. So please feel free to interact. Only thing is, like, I'll request all you to understand, since the participation is quite big. So unfortunately, we will not be able to I mean, accommodate, I mean, unmute you. So basically, like, again, but you can type in all your questions, queries in the chat window, right? So please feel free to ask your questions once, whatever queries you have. So with that, I'll hand over the session to Ritesh. Ritesh, let me make you the presenter. Yes, so I've made you the presenter. Whenever you are ready, please feel free to start.
Yes, can you all see my screen?
Yes, we can see your screen. Thank you.
Okay, great. Good morning, everyone. Sorry, just I'm having a bad throat today. So first of all, thank you very much, all of you, for coming over and being a part of this session. And thank you, Nitish, for organizing this in the first place. So as Nitish mentioned, that today's session is about two very relevant topics as of modern times: credit risk, and then you have the application of artificial intelligence and machine learning in credit risk. So what I will try to do today, the topic itself is a very, very vast ocean. So what I'll try to do today, I'll just try to give you a glimpse of what kind of artificial intelligence tools are used, how they fare vis-a-vis the traditional credit scoring tools, and then some of the opportunities and risks and challenges that artificial intelligence and machine learning models present. Okay. We all know what credit risk is. It's the risk that the borrower will not pay upon time, both in terms of lack of capacity to pay on time, as well as lack of willingness to pay on time. And as far as financial institutions are concerned, this is or a lending institution is concerned, this is the biggest risk that they have to manage, that is credit risk. Now, as far as the regulatory approach goes, you have the Basel Accords or the Basel norms, which act as a guiding principle for financial institutions around the world. They essentially permit banks to employ a credit risk management based on internal ratings. What banks typically do in order to protect their loss from each lending that they have made, they will design their internal credit risk model, or they might buy some third-party tool. And the essential idea is that the expected loss, the essential idea of credit risk is that expected loss EL is probability of default PD multiplied by loss given default multiplied by exposure at default. Now, there are different types of credit risks that you may come across. So the most common one is credit default risk, which is the non-payment risk. Then you can have concentration risk, wherein you have concentrated exposure to a single counterparty or to a set of related counterparties. That is concentration risk. You can have country risk, which is the risk of loss resulting from your exposure to a particular country, a particular sovereign state. This is also what we call transfer and convertibility risk. And then you have counterparty credit risk. This is also a form of credit risk, but this primarily is applicable to OTC derivative transactions. So the credit risk that you have in OTC derivative transactions, forward contracts, option contracts, swaps, credit default swaps, that is where counterparty risk comes into the picture. Now, I told you that banks typically manage their credit risk profile or the credit risk profile of their portfolio using some internal rating model. And the most common approach has been to assign to each customer a credit score or a credit rating. So when you have individual borrowers or SME borrowers, you typically have a credit score, which is a numerical score that you assign to the borrower. And when it comes to companies or large corporates or sovereigns, financial institutions being your borrowers, the approach is to take a credit rating, which is what credit rating agencies typically do. There it's an alphanumeric scale. Okay, there are differences between the two approaches. Let's focus on credit score for the time being. Essentially, credit score is a number which tells you how likely a consumer or a business, what is the probability of the consumer or the business who is your borrower to be able to pay the exposure in full in a timely manner. Okay. And the typical idea is that higher is the score, lower is the credit risk profile, or lower is the risk of default, better is the credit risk profile, and vice versa. Besides making the lending decision, the credit service provider or the bank or the financial institution, they may also use this score for what we call risk-based pricing. So you will use this score for three things. First of all is your lending decision, how much you want to lend. Now this will mean the amount and also the terms of sanction. For very high credit worthy borrowers, you may be willing to lend them on an unsecured basis. For lower quality borrowers, you might insist on a hard collateral, something that you can use for recovery if the borrower defaults. So for lending decision, for pricing decision, the risk-based pricing decision, and finally, you also use this for post-sanction monitoring of your portfolio. And how to take timely action in case the credit profile of the borrower changes from the time you have sanctioned the loan. Okay. Now, across the full credit cycle, if you look at the full credit cycle, there are different types of credit scores that a financial institution may use. The most common is the application score. This is when the borrower has applied for a loan. You use this to arrive at a decision whether you will approve the loan or whether you will reject the loan. Then institutions also use behavioral scores. These are based on known information about a borrower's historical behavior in different aspects of the credit life cycle. That's what behavioral scores are used for. You also have something called collection scores. Essentially, these try to depict the likelihood of the loan or the borrower further moving into delinquency based on different criteria about the borrower's past performance. It tries to depict whether a loan which is becoming problematic, whether that problem will be resolved or whether the problem will increase. That is what collection scores are all about. Then you have something called early warning scores. This essentially alerts the lending institution about an event, some internal or external event that may affect the credit risk of the borrower going forward. Very, very important for banks these days. Even the regulator in all the countries, they want the banks to have a robust early warning system so that problem loan accounts can be identified well ahead in time and timely resolution can be made instead of allowing the loan to become non-performing asset and then going for a bankruptcy proceeding or going for a loan restructuring. And fraud detection scores. Here, essentially, one of the big issues in credit risk is also about picking up fraudulent activity, especially in the retail credit or even in corporate credit for that matter, but especially in retail credit where you have these credit card frauds. There the lending institution might be very, very sensitive about picking up fraudulent behavior in time. So these fraud detection scores are used for that. So there's a family of scores that lending institutions would be using. Now, when it comes to assessing the credit score, so the whole idea is to assign a particular credit score to the borrower, a small business or the individual, which helps the institution to take timely corrective action. So typically you have three types of methodologies that institutions follow. The traditional approach, which is the statistics-based approach. This is the traditional approach. And then of late, people have been moving to artificial intelligence or machine learning based models. Okay, so another slide will tell you how these are the different computing techniques. You can see statistical learning. The most popular ones are discriminant analysis. I will talk about that in some detail shortly. Discriminant analysis or linear discriminant analysis. You have logistic regression and you have Bayesian models. And then you have machine learning models. We are going to discuss this also at a lot of length, where you have support vector machines, you have XGBoost, you have stochastic gradient boost, you have the K nearest neighbor, you have tree-related models, you have ADA-boost, bagging, boosting, and then you have the neural network or the deep learning based models, where you have things like artificial neural networks, you have convolutional neural networks, you have the recurrent neural networks. There is something called DBM, which is a deep I had written it here. It's a deep belief neural network. You have long short-term memory or the LSTM model. So the idea is to tell you that there is an entire taxonomy or there is an entire family, different families of models that institutions have been using to arrive at a credit score. And these are applicable to both retail and corporate customers. So this picture essentially shows you some of the application areas. As you can see, with regard to retail borrowers, it is used for credit scoring, credit risk forecasting, credit card fraud detection. And similarly, when it comes to corporate borrowers, assessment of corporate credit risk, doing supply chain finance, predicting bankruptcy, peer-to-peer lending, mortgage risk, All these are covered by these topics. Okay. Now let's look at them in some detail. The traditional methods in credit scoring. So initially when credit scoring started, it was more subjective in nature. It was essentially a reflection of the credit provider's gut feeling or their knowledge about the customer, but it was pretty subjective. In terms of creating objective models, scientific models, the traditional approach has been to use statistical models. Okay, and the typical approach that you follow there is something called linear model. This is also known as parametric approach. The thing about parametric approach is that you assume a certain functional form of the model. That could be a linear form, that could be a non-linear form, and you estimate the parameters of the model from the sample data at hand. That is why it is called a parametric approach. And typically when it comes to credit scoring, that you will have the input parameters, which will be used to form the model, and you will have the output parameter. So the input parameters would be the various risk factors. The borrower's income, the borrower's past track record, their payment track record, how much limits they are availing from different financial institutions, what is their repayment obligation on a monthly basis, what are their demographic characteristics, gender, education, all those things. They are all considered to be the risk factors, and the output or the dependent variable would be a PD, probability of default. So the idea is that you create a model which is able to explain or which is able to correlate probability of default to these risk factors. And the first statistical models that people started using was something called discriminant analysis or linear discriminant analysis. The idea about linear discriminant analysis is if you have a set of data points, you try to figure out the parameters. It could be a single parameter or it could be a combination of parameters. You try to find out the combination of parameters which are able to divide the set of data points into different groups. That is why it's called discriminant analysis. You are searching for the set of parameters or the combination of parameters which are best able to discriminate or differentiate between the groups. And when it comes to credit scoring, you are essentially trying to bucket the past sample points into two groups, those who have defaulted and those who have not defaulted. So default and non-default. Okay. And what the linear discriminant analysis tries to do, it tries to maximize the separation. Mathematically speaking, it tries to maximize the separation between distressed entities or bankrupt entities or defaulted entities versus credit-worthy entities using some kind of a linear combination of the most relevant risk factors. And this technique was first used by Sir Ronald Fisher in 1936. Okay, this was the first statistical method people ever applied to systematically explain as of which firms can enter bankruptcy based on a set of accounting and financial variables. And the best example of this model is the Altman Z-score, which was given by Edward Altman in 1968. So this is the original Altman Z-score model, which he developed using data of publicly held manufacturers. He came up with this scoring formula where X1, X2, X3, X4, X5 are the different factors. X1 is working capital by total assets. These are all ratios. So using a combination of these ratios, he calculated a certain score called the Z-score, and then he gave a range. For example, he defined a threshold, and he said that there are 3 areas. If the Z-score is over and above the threshold, then it's a credit-worthy entity, no default. If it is less than a certain level, then very high chance that it can default. And finally, you have the middle zone where you have to keep monitoring. Okay. Now, linear discriminant analysis essentially works. This is a visual representation of what is happening here. So you can see there are 2 sets of data points. The orange ones represent past customers who have defaulted, and the white circles represent customers who have not defaulted in the past. And you are trying to find some kind of a mathematical equation which can segregate these points into 2 different groups. Okay. Of course, there would be some spillover. So as you can see, these customers did not default, but still they have been segregated on the other side. Linear discriminant analysis essentially makes a lot of mathematical assumptions. For example, it makes an assumption that the variance within each group has to be homogeneous, which means for all levels of independent variables, that is parameter x1 and parameter x2, variance has to be same, or what we call the property of homoscedasticity. Then it assumes that within a single group or a single class, the data points are distributed as per a multivariate normal distribution. Then it assumes that there cannot be any multicollinearity. Why? Because if the independent variables are highly correlated, then the accuracy of the entire classification algorithm drastically reduces, and it also assumes that the observations are independent of each other. Now, LDA has a lot of advantages. It's very simple in terms of estimation, in terms of representation of results. It has a very decent predictive power as long as its assumptions are met. For example, the Altman Z-score has been a benchmark for a very long time in the financial services industry. Okay, and LDA, or the linear discriminant analysis approach, works not only where you have big training data sets, but also where you have smaller samples. But the major problem with this technique is it makes very strict assumptions, especially the assumption about multivariate normal distribution. It is never met in the real financial world, and as a result, the outcome or the output of LDA or linear discriminant analysis is highly sensitive to outliers. It's highly sensitive to outliers. So that is a major problem with this technique. Then the second statistic that we have been using, this is again very popular, is logistic regression. This belongs to the family of regression-based algorithms. It's a linear classifier. And this is used for so unlike linear regression, where you are trying to predict the numerical value of some output variable, here you are trying to predict the category of the output variable. So it's a classification algorithm. And this is the typical format of the logistic regression model. It resembles the classical linear regression model. The only difference is this output variable that you are trying to model. It is in this format. This is called log of odds. So you are modeling the log of odds as a linear combination of independent variables or explanatory variables or inputs. Okay. First, the probability P, the number between 0 to 1. Okay. Let me show you how this looks visually. So you are trying to model the log of the odds. So say this is a single parameter just for the sake of representation. There is a single parameter x1. So you are trying to model the log of the odds. And this is the fitting line. Okay. And using the log of the odds, you can derive the estimated probability. What happens is, I told you that you have modeled the log of the odds as a linear equation. From this equation, you can compute the probability of default. Is P, that essentially becomes e to the power this divided by 1 plus e to the power this. And typically what the credit scoring models do, they will, the credit decisioning models, for each borrower, they will compute the probability of default, and then they would have a threshold probability. Depending on the risk appetite of the financial institution, if the probability of default is less than the threshold, then the decision will be approve the loan. If the threshold is exceeding if the probability of default is exceeding the threshold, then the decision would be to reject the loan proposal. Okay. And so this is the log of the odds. This is the linear model, but when it actually goes to probability of default, this is how it looks like. An S-shaped curve, also known as a sigmoid function. Okay, and how you exactly fit it? Unlike a linear regression model where you use a technique called minimization of the sum of a square of errors, here you use a different statistical technique called maximum likelihood estimation. I mean, when you have to fit the model, fit the data points to the model, or you have to fit the model to the data points, in linear regression, the line of best fit was the line which minimized the sum of a square of the errors. So you computed the residual sum of squares, you took the sum of these squares of errors and you tried to minimize them. Here, you use a different statistical technique called maximum likelihood estimation. It's a very commonly used technique for statistical modeling. And the essential idea is you choose a model, the best fit model is the one which maximizes the joint probability of the sample that you have at hand. Meaning, if you already have a sample at hand and you are trying to figure out which model should I fit to this sample, the answer is we should choose our model in such a manner that the joint probability of observing all the sample points gets maximized. That's called the maximum likelihood estimation technique. Okay. Now, logistic regression or logic regression again has been a very popular technique. But again, it has several advantages and disadvantages. One of the limitations of logistic regression is, and this is very relevant to credit risk modeling, logistic regression ultimately is a linear model. Whereas in real life, a lot of times the relationship between the risk factors and the default event is highly non-linear in nature. So wherever you are encountering non-linearity, there this linear model would not be a good fit. So you will have a problem of what we call underfitting the model, because the sample data has a lot of non-linear relationships which you are trying to model using a linear approach. Okay. Another big problem with this approach is it requires a large size of training data. It is also very sensitive to outliers. Okay. Also, all the traditional scoring techniques, they essentially rely on historical financial data, credit history, loan repayment, income levels. And therefore, these traditional scoring models, they often struggle to accurately assess individuals who have limited or non-existent credit histories, young adults, immigrants, those who belong to underbanked communities. So there is the entire problem of financial inclusion as far as these traditional scoring models are concerned. And one of the reasons that we have been going towards artificial intelligence or machine learning models is because there you can use alternative data sources, non-traditional data sources like social media activity, utility and rent payments, e-commerce transactions, employment history. And when you combine these alternative data sets, in a lot of cases, you might have a more nuanced credit profile of the customer, which traditional approaches may not consider at all. Okay. Let me just walk you through some of the common machine learning based models that we have. The first set of models is those which are based on classification trees, or what we call decision trees. They are used for both regression and classification purposes. We are talking about a classification tree here. You can see it looks like a tree, and the purpose of the tree is to compute the probability of default. And you can see here the entire structure of decision making, it is modeled as a hierarchy. So at every step, you apply a certain criteria, and based on whether the criteria is satisfied or not, you break up your sample data set into two buckets, and you keep doing this. Okay, and finally, so this is the root node. And finally, you have the leaves. So in this case, for example, you can see this is a decision tree or a classification tree which is being used for credit default classification. Here the root node has been identified as annual gross income. Okay, and at the bottom you can see the final green nodes. These are the leaves. These tell you what was the number of defaults in each bucket. So you can see there was a bucket where 107 defaults were there, and the probability of default was 89%. Another bucket, probability of default 11%. Now what happens is, how do you interpret this tree based on this root node alone? What this tree tells you that if the annual gross income of the borrower is more than 10,500, if it is more than 10,500, then the probability of default is 6%, because in that particular bucket, 94% did not default, only 6% default. Whereas if you have the sample with annual gross income less than 10,500, now depending upon whether the loan is secured or unsecured, if the loan is secured, then the probability of default is only 2%. Whereas if the loan is unsecured, then the probability of default is 89%. Okay, and one question that might come to your mind is, how do we actually decide upon this tree or the various characteristics that are used to grow the tree? The answer is, you don't decide it as an individual or as the user. You let the algorithm itself figure out which is the most relevant factors by which the tree should be grown. Okay, and typically one mathematical criteria that we use is something called a Gini impurity coefficient. Okay, this is something that is used to bifurcate the tree at each node. Now, clearly you can see that classification trees result in a decision tree structure which is highly interpretable. That means you can really explain to someone how the credit decision was arrived at. So the point is, you have created this tree based on the historical sample. The next time a borrower comes to you, you will try to figure out based on the borrower characteristic which leaf node they will ultimately lie into, and that will be taken as a proxy for the probability of default for that new borrower or the borrower who has applied for a loan. Okay, so it's highly interpretable, plus it is very, very good at modeling non-linear relationships between the outcome variable, that is the probability of default, and the input parameters. Okay, also trees are very, very good in terms of dealing with missing values. The only problem is they have several limitations as well. First limitation is they often result in what we call overfitting of data. Overfitting means that the model is able to explain the sample data very well, but the performance of the model on out of sample data may not be very high. This is also said to be the case of the model having a high variance, which means even if you make a minor change to the training data that was used to train the model, the results of the model may be very different. Okay, so this is the decision tree model, single decision tree model. An improvement upon that is something called a random forest. This is an ensemble method. Ensemble methods mean a technique where instead of using a single algorithm, you use a collection of algorithms. So you can see in the random forest case, instead of relying upon a single decision tree, you grow different decision trees. And there are techniques to do that so that the same tree does not appear every time. You grow different decision trees on the sample data, and then you poll each tree, you get the outcome from each tree, and whatever is the majority outcome, majority voting or averaging, that is the final result of the random forest. In general, they will have a higher classification accuracy compared to decision trees, because the result that you are seeing is the majority result of different decision trees, or it's the averaged out result of different trees that have been used in the forest. Okay, the only challenge here is that in order for this technique to be effective, you have to somehow grow different decision trees which are uncorrelated to each other. If the different trees are uncorrelated to each other, it means that the forest as a whole is able to consider different possible combinations of features and the training data sets, and as a result, the model will be much more robust in terms of processing new data. Okay. Of course, as an ensemble approach, in terms of overfitting or in terms of variance of the individual decision trees, it's a superior approach. It prevents the model from overfitting. Another advantage of random forest is that it can handle missing values. Okay. Limitation of random forest is highly in terms of interpretability. I mean, the decision tree was much easier to explain to someone, but how do you explain the output of the random forest, which is much more difficult. Okay, and another limitation is it is very, very computationally intensive. Then you have a technique called gradient boosting. again a part of classification tree based methods. It's an ensemble approach. But here, see what you are doing in random forest, you are creating different trees and then somehow averaging or taking the majority of the decisions of each tree. In boosting, what we do is you add the decision tree stepwise. The idea is to keep reducing the model error. You can see here, prediction from each model gets combined for the ensemble prediction. So you start with a decision tree, then you try to figure out which were the aspects on which that decision tree was faring poorly. Then you add a decision tree only focusing on those observations where the previous decision tree was not very good. So at every step, gradient boosting will decrease the variance and the process will keep on repeating until you reach a point where adding a new decision tree does not have any meaningful impact on the, does not result in any meaningful incremental impact on the accuracy of the model, the classification accuracy of the model. And finally, all the individual decision trees will be combined in an ensemble, which will be used for further classification. Very powerful classification method. Challenges, interpretability of the model result is very low. Why? Because why interpretability is so low? Because you have a large number of hyperparameters here which have to be tuned manually, and they can have a big impact on the model's structure. So this is the classification tree approach of machine learning to solving the problem. Then you have clustering approaches. Here what you try to do is you try to obtain natural grouping from your data. I didn't use the word class because you did not know the class label beforehand. You did not know, unlike the logistic regression approach or unlike the decision tree approach, you did not know which of the borrowers had defaulted and which of them had not defaulted in the past. Okay, the idea is clustering itself has to generate the label. It has to somehow segment the data points into natural groupings. The most common clustering technique is something called a k-means clustering. I'm just showing you a very simplified approach as to how k-means clustering is conducted. You start with the data, you choose some initial cluster centers, then you compute the distance of each data point from these two cluster centers. And whichever distance is small, you assign the data point to that particular cluster center. So you assign each observation to the nearest cluster. Then what you do, you recompute the cluster centers, reassign observations to cluster centers, and keep doing this until you reach a point where there is no incremental benefit of repeating the exercise again. That is what you do in k-means clustering. Then you have another clustering approach, something called a hierarchical clustering. Now in k-means clustering, you decided a priori how many data clusters you wanted. In hierarchical clustering, you don't do that. The way you approach this is you assign all the data points as their own cluster. That means each data point represents a separate cluster. Then based on the Euclidean distance, you will combine the two nearest data points and merge them together to form a new cluster. So you started with, say, suppose you had I data points in your sample. Then you started with I clusters, each data point being assigned to a separate cluster. Then the two data points which were most similar to each other, you fuse them together into one cluster. So from I, now you have I minus one cluster. And you will keep repeating this exercise until you achieve convergence. A good part about hierarchical clustering is that unlike k-means clustering, the representation is like a tree. It's called a dendrogram. For example, you can see here, you started with a set of data points, and finally, by the process of hierarchical clustering, you have divided these data points into 3 clusters. This is how hierarchical clustering works. And then we have what you call neural networks. The basic idea behind neural networks is that instead of organizing data to run through some predefined mathematical equation, you are training the algorithm to learn and recognize the pattern on its own by using many layers of processing. That's what an artificial neural network does. And the basic unit of an artificial neural network is something called a neuron or a perceptron. I'm giving you a very simplified example. Here, you have to predict the value of a house using 2 features, the overall quality and the living area. Now remember, in traditional statistical based approach, what you would have done, you would have tried to explain the house value directly in terms of the features. But in the neural network world, that's not how you proceed. Here you have 3 layers. You have the input layer, which contains the 2 features. You have the output layer, which predicts the house value. And you have the hidden layer or the processing layer, which consists of 3 neurons. Now, what do these different terms mean? Effectively, what you have done is each of these things, okay, this is a model parameter also known as the weight. What it does, it links the value at the kth neuron to the jth feature. So, model parameter like WJK means the weightage or the linking of the jth feature to the kth neuron. So here, because you have 2 features and you have 3 neurons, so you will have a total of 6 weights. Similarly, you have these model parameters, call them UK. This is also a weight, but what does this do? This links the value of the target, what you are trying to predict, to the value at the kth neuron. And finally, you have these. This is the value at neuron K, which is calculated by the model itself. Okay. The key point is that the artificial neural network is not directly linking the feature to the target, but it is going through the hidden layer or the processing layer. Now, what happens is, I'll just give this in brief. There are 3 essential steps on how you work with the neural network. In the first step, each feature, that means each xj or the jth feature, will be multiplied by the weight which connects it to the kth neuron. So if this is what you will do for feature number 1, you will compute the linkage between that feature and the first neuron, and you add up the results. Okay. Then you add a constant, which is a model parameter called the bias. And finally, you apply a function which is known as the activation function. So you will calculate V1, V2, V3. So V1 will be some function of a model constant plus W1K X1 plus W2K X2. Here will be 1 and 1. This is how you will compute V1, V2, V3, and finally you will compute H. And then you will use some kind of an activation function. And the simplest activation function that people use is something called the sigmoid function or the logistic function that you also use as part of the logistic regression. Okay. And the idea is you will define some kind of a objective function. You will define some kind of an objective function, also known as a cost function or a loss function. And in every iteration, the model will try to reduce that cost function or minimize that loss function. And you keep doing this iteratively. So I mean, one iteration of the neural network will be completed, then there will be a feedback loop, and the iteration will again be done. By the end, by the time you have finished calibrating the model, you would have figured out the most optimal weightages which result in the best possible prediction of the house value. That is how the artificial neural network or the deep learning approach works. Here it was very simple. I'm showing you a simplified example of how a neural network can be used for loan classification. So you have 4 features: credit score of the individual, income, debt to income, and what he owns, whether he owns the property or whether he lives in a rented property. Just a hypothetical example. Based on these 4 features, you are trying to use a neural network with a single hidden layer, 3 neurons, and you are trying to compute the probability that he will not default. Okay. This is a simplified case because you only had 1 layer of neurons. You can have multiple layer of neurons, and that will result in what we call the multi-layer ANN. Okay. Power of neural networks is they are very, very good at identifying highly complex non-linear patterns in multi-dimensional data. Flip side, they can be prone to overfitting. Of course, there are techniques to mitigate that overfitting, but they are prone to overfitting. And whatever empirical research people have conducted till now, machine learning models, especially neural networks, as well as gradient boosted models, they have been shown. I mean, the whole challenge with credit data is a lot of the data set is proprietary. So whatever publicly available credit data is available, and normally the researchers work with a data which is a part of a UCI repository. This contains some credit related data from Germany and Australia. This is what researchers have typically used, and they find that gradient boosting models as well as neural network models may have a better classification accuracy compared to traditional statistical models. Okay, so that is there. A major issue is how do the AI models perform? I mean, how do they work in terms of performance versus interpretability? This picture is tries to give you a brief idea. So you would want a model to have high classification accuracy. So you can clearly see that when it comes to things like neural networks, neural nets, and deep learning, their classification accuracy could be quite high. But the problem is a lot of these models having very high classification accuracy also suffer from the problem of very poor explainability. Okay, so you can see here, unlike this, if you go to the traditional models, the statistical models have lower classification accuracy, but they are more explainable. Similarly, decision trees, explainability is quite high, but they may have lower performance due to overfitting. Okay. Again, a lot of empirical research shows that the accuracy of whatever AI method that you are using is highly dependent on the training data set, and therefore there is no universal technique which is superior to every other technique across the board. That is something that has to be remembered when you are designing the model. Okay, now let's talk about some of the opportunities and the risks that you have here. Opportunity is financial access and inclusion. So as per data provided by multilateral institutions like World Bank, around 2 billion people across the globe do not have a basic bank account. Okay, and similarly, there are hundreds of millions of MSME, medium and small scale, micro, medium and small scale enterprises across the world, across the globe, especially in emerging markets, who do not get adequate financing because they do not have a long enough credit history or because they are not able to provide collateral. Okay. There, as I told you, artificial intelligence or machine learning models can serve a very useful purpose compared to traditional scoring models because they are able to take into account alternative data sources Okay, so if there is a consumer who has a very short credit history, they may not satisfy the lending institution's traditional lending requirements, but some fintech who is using a machine learning model that is based on alternative data scoring techniques, they might find them a credit-worthy borrower. Okay, of course, automation of process is there because you are able to automate the entire credit scoring process. So the cost of making the credit decision and the cost of performing the credit monitoring, all that gets reduced. And you have a better customer experience. Why? Because you are widening the variety of analytical capabilities and you are increasing the size of data sets that are being analyzed. It means it can provide you deeper insights about your customer pool and you can give them a more personalized experience and you can develop more relevant financial products for your customers. And of course, finally, a better predictive model means more accurate decision making. And this is very important for banks because remember, banks are a regulated industry. And typically for every 100 rupees of loan that a bank makes, they have to keep 10 rupees in capital. And what does the bank make on this 100 rupees? If you look at the NIM or the net interest margin that they make, that means the rate of interest that they charge from the customer minus the rate of interest that they pay to the savings account and the term deposit holders, the NIM is say like 3%. That means for this 100 rupee loan, the bank has to keep 10 rupees of capital, but what they make on this is only 3 rupees. By any chance, if this loan goes bad and if they lose this 100 rupees, then in order to make or get back 100 rupees, the amount of loan that they will have to make will be not a fresh 100 rupee loan. That amount of loan has to be much, much larger because on every 100 rupees, you are actually making as income only 3 rupees. So banks are very, very sensitive in terms of making good credit decisions because of the regulated nature of the industry. So if you use innovative algorithms, it can improve the overall quality of credit risk assessment and you will be in a better position to assess your customers or your portfolio's credit risk. And at the same time, a better assessment of credit risk allows you to do a more rational risk-based pricing. You can offer more competitive interest rates to your customers if you are able to assess their credit risk better than using the traditional scoring approach. This is an example of a company called Nova Credit. They are a cross-border service provider and they have been trying to solve the problem of credit access for immigrant population. This is in the US. And this is primarily done through integration with credit databases internationally, which allows the lending institution global access to a single API. And they provide a service to expatriates and immigrants from these countries. And essentially, if someone migrates from India to US, they have to make available their previous credit history when they are applying for financial products in the US. So this is quite a good thing to do. In terms of risk, I think the biggest problem that AI models or the biggest challenges that people have been facing with AI models are whether these models are fair and how do you interpret them. Okay. For example, algorithms which are searching through alternative data sources, they may detect personal data which can have legal or ethical restrictions like race, gender, the religion of the person. Okay, so normally countries do not allow you to make credit decisions based on such demographic factors. In fact, there have been some research which talks about the fact that if you use big data, then it can lead to bias against communities which have already been deprived. That's what this research conducted in US talks about. Okay, and another big problem is how to interpret the model result. This is very, very critical for the central bank or the regulator of the financial institution. That how did you arrive at that credit decision? Because unlike the traditional credit scores, which are based on statistical models, especially when it comes to some of the machine learning algorithms like random forest, gradient boosting, you have and artificial neural networks, it's very difficult. It's a black box model. Very, very difficult to explain to someone how did you figure out or how did you arrive at the decision. So there is a lack of transparency, a lot of opaqueness. Okay, and when these opaque models or black box models are used to assign credit scores to make credit decisions, then from the regulator's perspective, that decision is not explainable, and therefore it's a challenge with them. Okay, and this is not only a micro level problem, this is also a macro level problem. So if a model that is being used by the bank for making credit decisions cannot be explained or it cannot be interpreted properly, then it can also lead to macro level risk. And that is why you are having a lot of work done these days on what we call explainable AI. That means AI models which have good prediction accuracy, but at the same time, their outcome can be explained. And again, the typical problems of data privacy and data security, especially cyber security, that remains the case with AI models. So that's pretty much all that I wanted to talk about. If there are any questions, I'll be happy to take. Yeah, over to you, Nitish.
Bro, it was wonderful actually. I mean, in such a short span of time, I mean, you could give such a good overview. So I think, like again, participants have got a very, very good idea about like overall where we are applying these models in terms of credit risk. So it was a great summary session. Thanks for that. Before we go into the Q&A, maybe just to give you a breather, I mean, maybe I'll just very briefly speak about what we have been doing at IIQF and how we are promoting all this field of quant risk and all these areas, right? So very briefly, all we'll take up the Q&A. But before that, actually allow me to just like briefly mention about the work that we have been doing. Right. So quickly, I mean, by the now, actually, most of you know about us, but still, just for the sake of a little introduction, I represent Indian Institute of Quantitative Finance, and we are a body which specializes in education and training in this advanced analytical areas of finance, be it quantitative finance or financial engineering, risk management, quantitative algorithmic trading, artificial intelligence and machine learning applications in finance. And we were founded by, of course, top pioneers in India and top experts from the field of risk management, financial engineering, and investment banking. So that's pretty much about us. And I mean, for more than 1.5 decades now, we have been tirelessly promoting this field of quant finance and financial engineering in India. We are the oldest quant finance body in India, right? So, I mean, since we are speaking about risk management and machine learning, so anybody has an interest in making a career in risk management in particular, or maybe in a broader sense, careers in financial engineering or the quant, or maybe the machine learning or data science specialist in finance, we have a plethora of courses which one can take up, which are very comprehensive, deep courses which are done through online, live, and interactive sessions, specifically designed for people who can do this along with their job, or if you are studying, you can do along with your degree programs as well. I mean, anybody has an interest in making a career in this field, we do have courses to suit everybody, right? So starting with the courses in financial engineering and quant finance, so we have a course called certificate program in financial engineering, a maths heavy course, to be honest, where people generally from engineering or mathematics statistics background, if somebody has an interest in becoming a quant, they can look at this program. I mean, it's like a course which goes deep into the mathematics and then the mathematical applications and the mathematical modeling in finance for derivative valuation, pricing, risk management, and all that. I mean, for those who are not keen on going into very heavy mathematics and learning the quant and risk management, particularly a little bit more focus on the risk management, then I can look at a course called Certificate Program in Quantitative Finance and Risk Management. It's a 6 months program. Again, these are all weekend online live lecture based programs, as I mentioned. This is of 6 months. Again, it covers all aspects of theoretical understanding of derivative valuation, pricing, and risk management. Yeah, and both these courses also have modules on machine learning and its applications as well, right? So then for those who are interested in like maybe exploring options in algorithmic trading, we have a very comprehensive 8 months course called Postgraduate Program in Algorithmic Trading, which essentially teaches all aspects of algorithmic trading using different kinds of strategies, maybe technical analysis and price action strategies, going into machine learning model-based strategies, quant model-based strategies. So that is also something one can look at. And now coming to specialized courses in data science, machine learning applications in finance. So we have a course called AI for Finance, which is pretty much it's the umbrella course in this field, which covers modules on data science for finance, machine learning for finance, and then depending on your interest, you can specialize in areas like AI for risk management, AI for derivative valuation, AI for trading, generative AI in finance. The AI for finance, the good thing is it can be done in a modular way as well. So if somebody is not interested in doing the entire 9.5 months course, you can do the part modules as well. So you can maybe do a course on machine learning for finance, which would be for 4 months. You can learn only the data science for finance part, which is of like 3 months. Or you can, this elective modules, as I was talking, there are 4 electives can be taken up separately as certificate programs as well, right? So as an individual module level. So as I was mentioning, AI for generative AI for finance, AI for trading, AI for risk management, AI for derivative valuation and risk analytics. So anybody having an interest in making a career in this field, we have something for all of you, right? So I mean, whether you want to become a quant or a risk management expert or an algo trader, quant trader, or maybe an expert in machine learning or data science applications in finance. So these are things we do. Yes, and it has been a long journey. We have been lucky to have so many students and professionals doing our courses and utilizing them to make a mark in their career, particularly in terms of quant and risk. A small example of like some who have been kind enough to share their thoughts on how they have used these courses. So I mean, it is for you to understand as a professional or a student how you can use these courses to make a further career in this field. Excuse me. Right. Yeah, so I mean, all the courses, we do have a placement support system as well. So it's not like you're just doing the course for sake of doing it. I mean, there's a strong placement support system which starts from absolute beginning, from the point, even if you do our course, whenever you touch base with us to explore our courses, it starts with the career counseling, understanding your background, and then maybe discussing what is the right approach, right kind of courses to suit your background, and then overall your what do you call aspiration and your career goals, right? Then, of course, once you do the course is all the courses are invariably taught by leaders from the industry like Ritesh, and there are like a huge plethora of like experts that takes you through the different modules. They're all industry leaders. So I mean, and they are there for your career mentorship as well of the finish of the course. And of course, we do have a dedicated placement support team. Once you successfully complete any of these courses, then the team will work with you on your profiling, resume building. They would work with you on interview preparations. They would and then they will of course try start approaching for different roles in the various kinds of organizations depending on your background, be it the international banks or the trading desks or hedge funds or maybe like again the other banks or financial institutions, IT companies, consulting firms, wherever this kind of opportunities comes. And I mean, according to your profile, they will take your profile, they will get you the interview calls, right? So of course, being a very, I mean, the oldest quant body in India, the industry network is pretty strong. And I mean, even the students and alumni in the last 15 years, a lot of them are in like leadership positions now. They also recruit faculties, as I mentioned. They are anyway leaders from the industry. They recruit themselves as well. So yeah, I mean, it's a strong placement support and career guidance. So I mean, the companies you might target are like companies like hedge funds, Renaissance Technology, DSOC, Citadel, Millennium Partners, banks and investment banks like Goldman Sachs, Morgan Stanley, Deutsche Bank, JP Morgan, Citibank, Nomura, to name a few. Of course, the stock exchanges like NYSE, NSE, and all. And the big four consulting firms, of course, EY, Deloitte, PwC, KPMG, and all these guys, they recruit heavily in these fields nowadays. IT companies, of course, the MNC ones, Accenture, Cognizant, TCS, to name a few. And yes, maybe we have missed adding here, a big set of organizations recruiting nowadays are like the new age fintech organizations, particularly those who are specializing in the machine learning related areas, data science related areas, right? So this help is always there. Yeah, I mean, so yeah, so basically like again, a small set of associate companies, the kind of profiles that you can look at, the companies, and then of course as a part of our endeavor, we continuously work with I mean all the leading educational institutes to do our bit to promote this field. I mean, this is just a small list. I mean, just like again this month itself, we'll be going to IIM Ahmedabad to participate and like conduct I mean our contests and webinars, seminars in their inter-IIM meet, the Red Brick Summit, right? So I mean, this has been our regular endeavor. As I said, we have tried to do our bit in promoting the quant finance and the financial engineering field in India. Of course, it's a lot better than when we started out. The awareness is much more, but we'll still continue to promote this field, right? Yeah, I mean, anybody having any interest in exploring not only about the course, I mean, in case you would need any guidance regarding this field, these are our contact numbers. Feel free to reach us. We'll be happy to guide you, right? I mean, anything you want to discuss one-on-one, I mean, in terms of career guidance, any course that you get interested, please feel free to get in touch with us. All right. So with that, we'll go to the Q&A session. There are a lot of questions that we have received. Let me try to collate them one by one, Ritesh. So I'll just collate the questions, Ritesh.
Yeah, sure.
Okay, so the first question is from Ravi Raman, and he has asked, how can a non-tech guy or person not having coding knowledge can use this AI ML for finance? As myself is not from a coding or engineering background. Okay, so this question, let me start answering, and I would request Ritesh to add your thoughts, but maybe like allow me to start answering this question, right? So first thing is, Ravi, whatever is your background, right? I mean, in current context, there are always avenues to learn, unlike past where actually learning something was a challenge. Now, the resources that are available to everyone, all of us, right? I mean, there's a huge set of resources. Any field that you want to make a background in, it's not that difficult as long as you are interested, right? So first thing is that, I mean, I mean, whatever is your background, coding will form a very important part if you are looking to work in machine learning, data science, and all this area. Now, don't get me wrong. I'm not saying that you have to become a programmer per se, but think of programming, particularly languages like Python and all, as like the tool that you would need to do if you want to work. You need to know if you have to work in this field. Just like, I mean, if I give an example, right? So, I mean, if you want to do company valuation, right? I mean, you need to use Excel. I mean, if you just study theory, you cannot value a company. You have to put data into something and then you have to analyze, build a model, right? So you have to use Excel. Similarly, again, the models here in this kind of industry are like complex. So tools like Excel, yes, you can do some basic work, right? But you need to have more advanced tools like programming tools like Python to actually build your models and do the analysis, because I mean, the huge set of data involved, very complex models involved, right? So essentially you need to use Python. Now, the thing is, as I mentioned, there are a lot of avenues to learn, right? And it is not as difficult as you think. Only thing is, a lot of time, many a times, what happens is finance professionals, they have a big hang up about programming. So, I mean, you just remove that hang up, come with an open mind, start learning bit by bit. I mean, for a non-programmer, learning programming can never be easy. I'm not saying that, but two things. One, if you plan it out, do step by step using good resources over a period of maybe 3-4 months, you would definitely get a good hang of the basics. And then it's a matter of practice, right? So for example, if you want to learn AI and its application in finance, so if you see that we have a course called AI for Finance, right? I mean, but if you have to do that course, right, ideally you should join any of the batch that you want to join at least 2 to 3 months before the classes starts, right? Because whenever you join, you get access to all the resources that we provide for you to learn the basics of Python, right? Now, Python, one of the reasons it has become so popular, there are a lot of reasons actually, but one of the main reasons also is that Python is relatively easy to understand compared to a lot of traditional languages, right? I'm not saying that it would be a cakewalk, but it is relatively easy, right? That's why it is used so much in finance and data science, right? Because people come from generally a lot of different kinds of mixed backgrounds, right? And I mean, if they are able to do, I mean, you will be able to do as well, but I mean, it would require effort definitely. But if you do a systematic effort, it is pretty much possible. Anna? So yeah, I mean, whatever background you come from, if you have to work in machine learning, data science, AI related areas, then you have to get comfortable with programming, and you have to get comfortable with some amount of statistical modeling and mathematical modeling, right? Ritesh, anything you want to add on that?
No, Nitish, I think you summarized it quite beautifully. Just one more thing to add, because the question also said that I don't have an engineering background. To answer that, you need an engineering background at all. Ultimately, what this requires is, A, you need to have the understanding of mathematics behind the algorithm. So you need to have some grounding in probability statistics and some of the mathematical tools. And B, because it's about credit risk management, you will need to have some domain understanding. That will also come with time. And as far as programming language go, Nitish said very correctly that learning Python is not very hard. And at some point of time, if you want to make a career these days in anything, programming, a limited amount of programming is something that we cannot avoid. Plus, there are these days these platforms like K9, using which you don't need any coding at all. You don't need any coding at all. So don't fret about the programming part or the non-engineering part. As long as you have a passion for getting into this, as long as you are able to develop the mathematical skills. Of course, maths will be required. There are no two ways about that. You can always make a entry into the field.
Absolutely, absolutely. All right. So I hope that answers your question. Actually, I mean, we'll be happy to discuss in more detail. I mean, please feel free to reach out, and I mean, we can guide you in case you're interested in how to go about it. The next question is from Rishikesh. I mean, let me know if you wish to take this question, or we can actually take it later on as well. So he has asked, what are the generative AI use cases for prudential risk regulations existing in the credit risk landscape? So would you like to take that question?
So again, the whole idea about using the generative AI at the end of the day is not uh, very different from what we have been talking about in terms of neural networks. It is it is a severe overlap over that. The main usage of generative AI that you can find, and the thing like large language model that we have been talking about here, is especially where I see in terms of credit risk management, a lot of time I lack good data sets. To me, it's very useful in generating synthetic data sets. First of all, synthetic data sets can be used. Otherwise, I don't see any big difference in generative AI versus the neural network approach. It's pretty much generative AI ultimately is a deep learning tool itself.
Okay, wonderful. So I hope that answers your question, Rishikesh. If you have a follow-up question on that, please feel free to put up. Going to the next question, it is from Pritish Pradhan, and he has asked, what is the full form of EAD?
Sorry?
He has asked the full form of EAD.
Oh, the formula I wrote, that expected loss equal to probability of default into loss given default into exposure at default. EAD means exposure at default, because see what happens is there are different kind of loan exposures where the exposure amount may not be constant in time. So for example, if you have a term loan, say you have a car loan or an education loan, it amortizes with time. So depending on when the time of default, when the default even crystallizes, the exposure may be different. This is very, very pertinent for derivative risks, because in case of derivatives, you don't know a priori what the exposure will be or what the MTM will be when the counterparty defaults. So I hope that answers your question.
Yes. So Pritish, I hope that answers your question. Any follow-up, please feel free to type in. We will be taking up again after we take the other questions. All right. So next question is from Abhinav, and he has mentioned how are behavioral scores different from collection scores?
So behavioral scores are different from collection scores in the sense what the collection score is trying to tell you. Once you have seen some amount of stress in the account, okay, now the issue is, how do you deal with the stress account? Now think about it. One approach could be that the financial institution goes all hammer and tongs. They tell the customer that, look, I don't know whether you beg, borrow, or steal and give me back my money, or I will liquidate your assets. That is one way to do that. The other way to do that, you realize that it's a good customer. It's a good customer. They do not have an intention problem. Probably they have some temporary liquidity problem or a temporary industry problem. But if we are able to provide them some additional financing lines, because see, when one of the toughest decisions is when the account is already showing some signs of stress, how do you justify giving additional financing? Because the regulator might interpret it as some form of evergreening, that you are trying to save your own loan. But more often than not, remember, it sounds very good in theory to say that, look, I will liquidate the assets. But if you go as a financial institution to liquidate the assets, you would not even realize 10 paise on a rupee. The best bet is that the promoter and the management which has been running the show, they continue to run the show and bring the company back into good financial health.
Absolutely.
So, collection scores essentially give you a glimpse in terms of what is the borrower's willingness to salvage the situation. Okay, because while you may want to save the company, but you also don't want to throw good money after bad. And similarly, collection scores essentially try to tell you, based on past sample data, that once a particular borrower with a certain set of characteristics has reached a certain threshold, what is the next likely event? Would they go further down, or do you think they will be able to come out of it? So all this will help you in terms of trying to figure out what is the best possible way to help the company come out of a problem situation. And if the behavior and the collection score tell you that, look, there is nothing left, then you go all hammer and tongs, you go to a bankruptcy court, you go to an NCLT. So those are the practical applications. Similarly, behavior scores, remember there is a huge time between when you sanction the loan or disperse the loan and before you are able to see the first financial non-payment.
Correct.
And the time interval could be years. It could be 1 year, 2 year, 3 year. Behavioral scores are very, very important in terms of trying to figure out if somehow you are seeing a pattern which indicates that the borrower or the management or the promoters, they are having some behavioral issues. These scores can help you, trying to salvage the situation early, have an early conversation with the promoter, try to figure out what is the extent of the problem, if it's if it's something which is random, or if it is something where the promoter has a problem of intent. Because remember,
Correct.
if the problem of intent, then no one can save the company, and the only bank which will be able to get out is the one who asked for repayment or refinancing earliest. So these are different scores which can tell you how the customer's credit profile is evolving across the life cycle. I hope that answers your question.
Right. Yeah. So I also hope that Vinab, that answers your question. I mean, of course, any follow up, let us know. We'll take it up again after the next question. I mean, after we take up the other questions. Okay. So next question is from Jitesh, and he has mentioned his question is how to compute Altman Z score for NBFCs and HFCs.
For NBFCs and HFCs, so the model will change. So this is
Right.
the Altman's score. See, one thing is Altman's Z score traditionally has been used mostly for manufacturing entities. The reason is financial institutions, they have a very different set of operating and financing characteristics. Okay, so I have normal, even if you try to apply Altman's Z score to financial institutions, the form of the model will change. See, what Altman Z score ultimately has done, he took a sample set of manufacturing companies, which included both entities which had defaulted, the entities which had not defaulted, and then he tried to come up with a mathematical equation saying which format or which formula has the best discriminatory power. That you can theoretically do for any industry. You can pick up a group of NBFCs or a group of banks, and you can try to apply the Altman Z score there as well. But of course, you have to keep into mind that they will have very different operating characteristics compared to manufacturing or service entity. Because
Right.
the sheer fact that unlike other institutions, banks, number one, are very, very leveraged dinosaurs. The level of leverage that they carry is very, very high. And banks essentially, they are, I would say, they reflect confidence and trust. So as long as enough people have trust that the bank will not fail, it will not fail. And the moment enough people start believing that the bank will fail, there will be a run on the bank and the bank has to fail. So it becomes like a self-fulfilling prophecy. So that is why even from a traditional credit rating perspective, if you look at how credit rating agencies, assess manufacturing or service entities versus financial institutions, those differences have to be kept in mind.
Correct. Absolutely. Okay. So I hope that answers your question, Jitesh. Going to the next question is from Suryans. Suryans has, in fact, a couple of questions. So one is, could you please share about how back propagation helps in NN? And this next question is why explainability matters. So though I think the explainability part, when he put the question after that, it was discussed in the session as well. But yeah, I mean, if you can take that also, I mean, and maybe if you want to add anything. But first question is, could you please share about how back propagation helps in NN?
Yeah, see, when it comes to back propagation, as I mentioned earlier, ultimately when you train the neural network, so back propagation is a term which is relevant for deep learning or neural networks. The whole idea is that the training process is iterative. So you have these neural networks called feed forward neural networks. and their backpropagation, which is an iterative algorithm, essentially is used to adjust the weights and the biases. Okay. So, and it could be using some kind of a technique like a gradient descent, or it could be using a stochastic gradient descent. The idea is you will never be able to achieve the best output in first iteration of the neural network. You have to train it iteratively. And that is what backpropagation does. It helps you doing that iteration, number one. And number two, when it comes to explainability, I think it's very important because the financial institutions, they affect the life of everyone. They affect the life of individuals, of companies, SMEs, and the central bank or the regulator across the world. And plus, there are legalities around this. So whether you go to UK, you go to US, any country in the world, they have these legislation and laws which says that you cannot discriminate against people in terms of provision of credit, in terms of access to credit based on their demographics. US has a law, for example, which says that everyone should have an equal opportunity to access finance. Now, how does the central bank ensure that the financial institution is not engaging in, systemic discrimination against certain classes? When it comes to India, for example, priority sector lending is something which is made mandatory by the central bank in India. But say for the purpose of financial inclusion, the central bank wants banks to lend to certain target groups. Now, how do they how do they ensure that you are not actually discriminating against them? That is why they would want any credit model or any model in the financial institution which is ultimately being used to take a credit decision, onboarding decision, approval rejection decision, computing the capital requirement. The central bank would want to be very clear that they understand how that model works. They don't want to have a black box model which cannot be explained to the regulator. That is why the whole idea of explainability is so important. And backpropagation, as I told you, ultimately, if I can just get you back to the diagram where I showed you this.
Shall I make the presenter?
Yeah, you can just make me the presenter again. I showed you this multi-layer artificial neural network. This was the feature, this was the target, and backpropagation, what it is doing is you are adjusting the weights based on what the output has been. That's what backpropagation is.
Right.
Okay. If you want to understand this in detail as to how it works actually, then probably we can connect again through Nitish, discuss about that.
Yeah, absolutely. Absolutely. All right. So going to the next question, I hope that answers your question in general, Suryans. Of course, if you have a follow-up, you can let us know. Next question is from Avinav again. So he mentions in India, how is the adoption of neural net or deep learning models on building credit risk models?
Fintechs are primarily using it. See, as I told you, when it comes to banks, banks being regulated creatures, even if they have the most promising technology in the town, there will be restrictions on when they will be able to use it. So banks, if you look at them, they are still using the traditional process. They are still using the traditional credit scoring models. But when it comes to fintech, some of the NBFCs, are they using it? Are they using neural networks? Yes, they are using it. A lot of this is also a research work kind of a thing, because you have to remember that when it comes to financial institution, the model of the algorithm should not only work on a single sample data set, it should have a track record. That is why,
Right.
despite all the flaws that there are in credit rating agencies' outcomes, you still stick with that because they have a very long history. Okay. So to answer your question, are many of them using it? I mean, if the question is, have we primarily moved to neural networks for credit risk prediction? The answer to that is probably no, we have not. But are we moving in that direction? I think where the implementation will actually happen is, instead of the banks going all out towards neural networks or advanced machine learning algorithms, my guess is they will continue to stick with the traditional models because they have worked for them in the past, and they will use these artificial neural networks or the machine learning algorithms as a additional incremental process. So you will
Right.
continue to work the traditional model, and then you will see that whether a machine learning approach or a neural network approach, can it give me extra insights or can it give me more information? I think it's going to be an incremental approach instead of, the going all out in favor of one against the other.
True. True. Absolutely. Okay. Going to the next question. It's from Rishikesh again. So he has mentioned, how are financial institutions striking the right balance between incorporating high-performing AI into their models, given the focus on explainable AI by regulators?
I told you, I mean, that's a big challenge, because on one end, the financial institution might think that it may be more accurate. At the same time, they will not rock the boat. So they are trying to, as you yourself use the word, Rishikesh, they are trying to strike that balance by taking an incremental approach. Further, if you look at where they are actually using it in a lot of cases, primarily in a bank, I think what at least I'm aware about, AI is currently being used in a big way for process automation in terms of how to improve the turnaround time for retail loan applications, how to make disbursements as far as possible. Can we use things like natural language processing and computer vision for doing KYC or for reading documents? That is where you are primarily seeing the application. In terms of the core credit approach, I don't think banks will be able to do that in a big way unless and until the regulator himself becomes comfortable.
Absolutely. All right. So going to the next
And
questions.
just as a follow on to that, and that is why where you will
Sure.
see these models being deployed, the early adopters would be fintechs, which are unregulated entities, so they are able to do
Correct.
those things.
Correct. Yeah, absolutely. Okay, so couple of questions from Gurneet. Okay, so first is, what kind of models can be used for fraud prediction? So that's the first question from Gurneet.
So all kind of, what kind of models can be used for prediction? So see, typically you have,
In particular,
sorry?
he has particularly asked about fraud prediction. What kind of models can be used for fraud prediction?
So the same kind of models. So essentially, for example, we talked about logistic regression. See, ultimately fraud prediction, like default prediction, it's a classification problem. The nature of the problem, mathematically speaking, is classification, that you look at a certain pattern and you have to figure out whether what are the characteristics of a fraudulent transaction. That is what you do in credit prediction also. You look at a borrower characteristic and try to figure out whether the borrower will default or not. So any algorithm, see, and that is the beauty of the entire thing. That's why I said you don't need to be an engineer for this. The idea is, mathematically speaking, the problems are of only two types. You either have a regression problem where you are trying to predict some numerical variable. That is what you are trying to do in a regression problem. Or you have a classification problem where you are saying that a particular sample point, does it belong to category A or does it belong to category B? So the essence of the algorithm will not change. All the algorithms that you are using to predict credit default, they all can be used to predict fraud also. Because remember, again, very similar to credit. At the end of the day, these are all predictions. It's a probability of default. No one knows for sure whether the customer will actually default in the future or not. Similarly, when you look at a fraud transaction or a fraudulent transaction, there also you have to come up with a probability of fraud. Now, if that probability of fraud is higher than your threshold, then you will take some remedial action. If it is less than your threshold, you will take some other remedial action. If it seems to be very, very high chance that the transaction is a fraudulent transaction and the amounts involved are large, then probably you will stop the transaction, because you might think that it can be tagged as an AML or anti-money under the anti-money laundering classification, and you will stop the transaction. But if you think that the probability of being fraud is not very high, then you might take some other remedial action. Say you will call up the customer and you will say that, look, sir, there has been a swipe on your credit card. Have you done it or not? So, I mean, the algorithms are all the same. They're all, any algorithm which can predict the category of a variable, they can all be used for fraudulent pattern recognition as well.
Absolutely.
Okay, including neural networks, including everything else.
Right. I hope that answers your question, Gurneet. So Gurneet has a follow-up question. Any specific course for quant programming with AI and ML? So Gurneet, all of these courses that I talked about, right? I mean, during my small presentation, they all have various degrees of quant modeling and programming, right? Depending on the course that you do, the focus area may shift. So for example, if you're doing the CPFE or the CPQF RM course, the focus is more on the quant domain side. In those courses, the machine learning coverage is relatively restricted, because the main intent is to teach you the domain side of quant and risk, right? However, if you want to learn in more deep the AI ML applications and in finance, then there is a specific course for that, AI for Finance, which teaches all aspects of AI and ML applications in finance, including areas related to derivative valuation and pricing and all that, where quant modeling is used. So, I mean, depending on what is your priority area, these are things you can particularly we can discuss more in detail, and then you might select a course which aligns with your overall learning objective, right? Okay, so now going into the next question, which is from Pritesh, and Pritesh has said, can you give a walkthrough of the wholesome credit risk modeling using neural networks?
Sorry?
So the question is, can you give a walkthrough of wholesale credit risk modeling using neural networks?
I mean, as far as the process is concerned, I told you at the end of the day, what you are trying to do as part of credit risk modeling is, the credit risk modeling has only three things. You have the probability of default, you have the loss given default, and you have the exposure at default. Okay, let's forget about this. Whatever models you are using, they are ultimately being used for these two predictions. A, what is the chance that the customer will default, or the chance that their credit quality will decline. So a default does not only mean that there has to be a full-fledged financial default. Say you lent to a customer which was double A rated, and if that customer credit quality comes down to triple B, that's also a significant deterioration in the credit profile. So that is what the probability default model is trying to figure, and LGD is trying to figure out that based on the kind of collateral that you are holding and other characteristics, what will be the recovery once the event of default has crystallized. So essentially, primarily what people see, again, predicting this one is also a very, very tough job, loss given default, because normally what happens is, it's not that you can simply take up the collateral and go and liquidate that. There will be legalities involved. You have to go through a legal process, bankruptcy process. So the primary use that we are seeing for neural networks is here. PD, how well you are able to figure out or estimate the probability of default itself, because rest of things though will come only after the default happens. If the default itself doesn't happen, then LGD or no LGD, who cares? So this is where they are doing it, and essentially the purpose of artificial neural, the way people are using artificial neural network is, again, in order to properly train the neural network, and that is a big challenge in credit scenario. Unlike making predictions for equity markets where you have lots of granular data publicly available, when it comes to credit risk assessment, you do not have publicly available data sets, large data sets, because remember, artificial neural network has no use if the training data set is small. It will not give you any incremental benefit if the training data set is small. Similarly, you might want to use a lot of, alternative scoring alternative data. What are the legal restrictions around that? Because especially if you go in Western countries, European Union, US, you have a lot of concerns around customer privacy. You need to have a right to consent from the customer if their data is being used for some kind of a modeling. So those challenges are there. But essentially, what neural network-based approach is trying to do, you try to collect a large enough data set, and then run the traditional models over it, like discriminant analysis, like naive Bayes classifier or a decision tree, and compare that with a neural network and try to figure out as to which gives you a better outcome, and then deploy that in the production environment.
Absolutely. Right. So I hope that answers your question. So we are already 20 minutes past our allocated time. So maybe in the next 7-8 minutes, we'll take few of the other questions quickly, and then we'll wrap up the session. All right. So Survi has asked, actually, her question is, actually, I'm doing machine learning, data science student. I'm learning these models you taught today, but I have no knowledge of core finance. How should I proceed in quant? Please suggest. Very simply, Survi, we are sitting in front of you with a bouquet of very comprehensive courses exactly to prepare you for that part, right? So, I mean, if you're looking to understand finance part of it, and then again, it's a great combination actually. I mean, having a core machine learning knowledge, if you really want to move into the quant side of it, look at like one of the domain level courses in quant. To be honest, I mean, you can look at our courses like CPFE or CPQFR, and globally there are one or two more courses as well which you can look at. But yeah, I mean, in India, if you're talking about this kind of courses, then definitely not because it is our course, but I mean, there are no better comprehensive courses than this actually. Ritesh, you want to add anything?
No, I think you have answered that pretty well. So,
Right.
yes,
I mean, yeah, just to add, actually, I mean, if you are looking to learn some other core areas of finance, you can do some general finance courses as well to add with your data science knowledge, maybe a CFA and all. Also, you can explore. But particularly if you're looking to enter into the quant side, then again, look for a quant domain level course. And our courses are definitely something you can look at if you wish. I mean, you can
and
call us. Yeah, sorry.
I would just like to add one thing. See, Purvi, that's your name, correct?
Survi, yes.
Yes, Purvi. See, uh, finance itself, Purvi, is a very, very wide area. We don't need to know everything about finance. The problem, the way you can approach this is you pick up a subset. So for example, if you want to get into credit risk modeling, then essentially you have to only pick up a subset in the sense as to how credit, what are the basics of credit risk, how credit risk is modeled, and how do the relevant variables as far as credit risk is concerned, how do they behave mathematically? That's all. So that is the domain expertise that you need. The other domain expertise that you might need is, okay, where do banks get their data from? What is the quality of that data? How do banks maintain those data? Those are the things. And then you need to understand the maths and stats behind that. So you don't need to become an expert in overall finance as such. You simply have to pick up a subset of finance in which you are trying to develop artificial intelligence or machine learning capability and work with that.
Yeah, you're absolutely right. You're absolutely right. So yeah, that's what. So yeah, I mean, very specific, or maybe I mean you can learn a little bit broader subset, say maybe like the entire risk management or like maybe the entire valuation pricing side. So yeah, I mean, firstly, if you want to go into quant, you may not need to start with the general finance. You don't need to understand balance sheet, profit loss, or those kind of corporate finance at all, not to start with. I mean, later on, if you want to go into trade modeling and all, some amount of it you might need to go, but not required in the initial part at least, right? So it's majorly, I mean, this quant is a separate area of study altogether, right? Anyway, I mean, we'll be happy to guide you in more detail. I mean, you can connect with us and we can discuss more on that. Okay, next question is from Amgothu Venkatesh, and his question is there any available course related to remote sensing and GIS using machine learning algorithms? So from my side, to be honest, it's not really my domain, and I would not be aware of any such courses. Ritesh, anything you would know on that?
No, I don't know about. I mean, we'll have to check that out.
Unfortunately, Amgothu, we are more specialists and domain side experts on the area of finance related things, right? So that is something, unfortunately, would not have much knowledge. But yeah, I mean, given that like machine learning has become so important in every field, maybe something related to that might be there, but not very sure.
I think the only thing I can say is probably you can go to this NPTEL.
Right.
Yeah, they might carry such a course. I am not aware about this, but probably you can check. They generally carry these kind of courses.
Yeah, absolutely. Science related courses also like are actually quite good there. So yes, I mean that is any, I mean, place you can look at maybe, but specifically we are not sure, to be honest. Okay, so going to the next question, it is from Russell, and he has mentioned, sir, I am currently pursuing a master's in financial engineering and I'm interested in a career as a quantitative developer. Could you provide guidance on the most effective paths to achieve this, including relevant skills, certifications, and experiences that would be beneficial? So, Russell, first of all, congratulations, you are already doing a master's course in financial engineering, and I'm not sure which university, but I mean, if it is like a generally, like most of the courses are quite deep and prepares you with all the necessary ingredients. If it's like a good course, then again, I don't think you need to do anything more. As an entry-level quant professional, ideally that course should give you enough ingredients to become eligible for most of the entry-level quant profiles, including quant developer. Yeah, of course, if you are talking about specifically targeting a developer position, then again, naturally the IT skills has to be absolutely at the cutting edge, right? So when more languages that you can learn, more options that you can give to your employer, the best it is, right? I mean, the more teams that you can work with. But otherwise, I think again, since you are doing a financial engineering master's degree program, and if it is like a good program, then the general ingredients that is required for working as in a quant should be there. If not, if you think that your course is not teaching you enough, again, of course, I mean, one-on-one, you can give us a call. You can connect with me also directly through our office, and I'll be happy to actually understand where you stand and guide you if something else is required. But in general, I don't think much is needed.
Also, Nitish, just a second for the gentleman who about the geoinformatics part.
All right.
Probably one thing which comes to my mind is normally all these activities in India are taken care of by ISRO, and ISRO has an Indian Institute of Remote Sciences. So they, as far as I'm aware, they offer some MSc courses and certificates and PE diplomas also. So probably that would be another good place to check.
Very good. Okay. Right. So yeah, some resources to check. Please do check out. Thank you so much, Ritesh. All right. Okay. So going to the last two questions actually. First question is from, or rather the next question is from Ram Shukit, and he mentions that could you please, I think there would be some words missing, but could you please how to select feature and implications of feature selection in a financial model? Were you able to understand that question?
I think again, it's a fairly wide field itself, but you have something called feature selection. I'll just give you an example. So, for example, if you have a data set and you are trying to figure out which is the best linear regression model, say a multiple linear regression model to use, there you are trying to figure out or estimate which are the most relevant explanatory variables. So this is called feature selection or feature engineering, and there are different mathematical techniques around that. If you want, we can discuss that in detail. I don't think I will be able to justify that topic in such a short interval of time, but it's a complete discipline itself and very relevant for machine learning, because bulk of the model's explanatory power ultimately comes from two sources: A, what is the training data set that you used, and B, which explanatory variables or combination of explanatory variables you used. And the third feature engineering is that normally we have seen that creating an overtly complex model may not be the most optimal thing to do, especially when you compare the results of that model on a test data set, not on the training data set. Training data set, so you can fit anything. Okay, so there the idea is to create a model which has an optimal size, which means which are the best features that I should select as far as the explanatory power of the model goes. So when it comes to, for example, the world of linear regression, you use things like adjusted R square. Then you use metrics like Bayesian information criteria. You use the IIQF information criteria. So there are different statistical techniques around that. Probably we can discuss if you wanted to at a later point.
Wonderful. All right. So I hope that answers your question. Next question is from Tanumai, and he has asked, can XGBoost be better than linear regression, and is ML models are welcomed well by Basel and IFRS 9, or trend is still statistical models? Okay. So, I mean, I think broadly you have answered that question in some form or the other, but again, if you want to give him more clarity on.
See, the thing about linear regression is, in any model, whenever you use a model, ultimately you will always have something that we call, is my screen visible, Nitish?
No. I mean, let me make you the presenter.
Okay.
Yeah, you can share your screen.
So there is something called a bias variance trade-off. Is it visible now?
Yeah, absolutely visible.
Variance trade-off. The bias variance trade-off, essentially what it means is a model with a high bias, linear regression. Because you look at any real world phenomenon, the relationship between variables is not going to be linear. It's going to be non-linear, especially for real world phenomena in the world of finance and banking. So what linear regression model do, they try to impose a linear structure on a problem which is otherwise non-linear in nature. So they suffer from high bias. That means
Correct.
they suffer from the problem of underfitting, which means if you test the performance of the model on the training data set, that performance will not be very great. The explanatory power on the training data set would also be, say, 50 or 60% only, but you will have a similar explanatory power on the test data set as well. That is the problem of underfitting. And then you have these advanced machine learning algorithms, whether it is random forest, whether it is boosting, bagging, whether it is neural network. These have what we call overfitting. Because they are very well adept, or they are well suited to understand, to model the non-linear relationships in the training data set. So what happens is it can explain the training data set very beautifully. So on the training data set, that the accuracy of classification is like 80%, 85%. But the moment you take it to a test data set, which or a real world data set, which it was not trained upon, the classification accuracy will decline dramatically. Okay. So whenever it comes to an algorithm, the idea is to have a trade-off. You need to strike a balance. Now, to answer your question, can XGBoost in general, overall, perform better vis-a-vis a logistic regression model? In my opinion, yes. In my opinion, yes, especially when it comes to credit data sets. I think it's a better model. The only thing is you have to be quite judicious and cautious in terms of what data sets you use, what is the quality of that data set. Because remember, because the linear regression model is simple, it means if you change the training data set, the deterioration or the change in the performance of the model will not be very large, because model itself was simple to begin with. But if you use a model which is complex, then the results may vary very widely depending on which training data set you use. So yes, XGBoost is a better model overall, in my opinion. The second part of your question, are banks using it in a big way? I don't think traditional commercial banks are still using these advanced techniques in a big way.
Not
They are
exactly
using.
bank. So his question is ML models are welcomed well by Basel and IFRS 9 or trend is still statistical models?
No, so they allow. So as far as IFRS 9 or because ultimately what Basel allows you under Basel 2 itself, it allows you an internal rating based approach. So the IRB approach is there. Theoretically under the IRB approach, you can use any kind of a model, whether it is a neural model or whatever it is. The only thing is because you are a regulated industry, whatever model you use, it has to be auditable. It has to be auditable, therefore it has to pass the grind of audit and central bank regulation. So there is no restriction as such, but does it mean banks are using it in a full-fledged way? No, because I mean, we are still, as far as the regulatory environment goes, it's still evolving.
Correct. So to summarize, this last part is the trend is still statistical models. I mean, it's more used.
Yeah, especially for corporate borrowing. So we still tend to focus a lot on credit rating agency, and that is essentially a statistical technique.
Correct.
But
Correct.
are we moving in that direction? I think, see, instead of focusing on what probably the banks are doing today, you have to realize a lot of things banks are doing is also because they are highly regulated entities. But if you look at the fintech space, good, I think that's the appropriate segment to look at. Are we seeing that progress in the fintech space? Yes, we are.
Yeah, I think that's like a good explanation, I mean, of course. So I hope that answers your question, Tanumay. The last question for the day. I mean, we'll take this up and then, of course, we'll wrap up the session. We're already 30 minutes past time. But anyway, good to have this discussion. Good to see the participation, and it was great that we could answer all the questions. Actually, the last question is from Suryans. So he has asked: are there any tools available in market which is widely used by banks for modeling credit risk, or do they build their own models?
Yeah, the answer to that is I'll give you the example of Indian banks, for example. So the smaller Indian banks or the mid-sized Indian banks, typically what they would do, they would buy a third-party tool. So agencies like CRISIL, ICRA, and there are other agencies which create these credit scoring tools, internal credit rating tools. And what the bank will typically do is they will buy the tool off the shelf, but of course they will calibrate the tool according to their portfolio characteristics. Okay.
Right.
Comes to international banks, they have kind of completely moved to a completely full-fledged in-house rating models where they create their own models because they have the manpower, they have the history of data available to create their own models. Because see, the whole idea is it's not only about creating the model, it's about having appropriate resources to backtest the model as well and explain the results of that model to the regulator and to the auditor. So international banks, they have by and large moved to the internal rating based approach where they have their in-house proprietary models that they are using because now they find that these models best explain their portfolio characteristics, their underwriting standards, and they are optimal as far as capital requirements or computation of capital requirement is concerned. When it comes to the Indian scenario, I think whether it's the private sector banks or public sector banks, especially with regard to corporate borrowers, we are still dependent upon what third-party providers have been giving us because the good part about buying a model from CRISIL or ICRA is they have already been doing these things for several years. Number one, they have the domain expertise. Number two, they have a much wider world on which they would have trained their model or calibrated their model compared to what a single bank could do. But of course, I mean, can a bank like SBI or ICICI do it? Of course, they can do it. It's more a matter of how they want to proceed about.
Wonderful. All right. So I hope that answers your question. So with that, we would conclude the session with that question actually. So first of all, once again, I mean, many thanks, Ritesh, for this wonderful session. It was really a great session, and thanks for your patience in answering all these questions. To the audience, thank you so much for joining. It was great to see the lovely participation, taking your time on a weekend and joining this session. So we'll conclude the session with that, right?
Okay.
And
Thank you, everyone.
thank you so much. So before we end the session, just a reminder, we would continue having this kind of sessions on various important topics as part of our IIQF deep dive with IIQF experts webinar series, where experts will come and speak on various topics of relevance in quant, risk management, financial engineering, algorithmic trading, machine learning, data science applications in finance. So keep track of our announcements for the future such webinars in our websites, in our social media pages. Of course, those who have been involved with us, have been registered with us, you would also receive intimations over your email and other modes, right? So keep track of all that. See you again in the next webinars. Lovely connecting with you all, and thanks for attending. Thank you.
Thank you very much, everyone. Thank you, Nitish.
Thank you so much. Thank you.